Good afternoon, flippers. Our video for today is video 3.9. Sorry, that should be a 3.8. Our unit is stop motion animation, and our objective is I will use and apply properties of isosceles and equilateral triangles. So, we need to go over isosceles and equilateral triangles, which you might remember from middle school, but now we're going to get a little more complicated. Isosceles triangles. Isosceles triangles are triangles which have two sides of equal length. And so in this picture here, you see these two sides, equal length, and then there's this side which is different from them. Now these have different names. The two sides of equal length are called legs, and the bottom is called the base. The top angle is called the vertex angle, so this is the angle between the two legs. And the bottom two angles are called base angles because they connect to the base. This is important so you know how to distinguish it from other triangles. You should take a moment to write down these properties. We'll be going over the important ones in a second on the next slide. Remember, the unequal side of an isosceles triangle is always referred to the base, which means the two equal sides are the legs. The base angles of an isosceles triangle are always equal. We'll talk about that in a second. And when the third angle is a right angle, the whole triangle is called a right isosceles triangle. Moving on. What's really important about isosceles triangles is that if you have two sides that are congruent, then you know the base angles are also congruent. So for example, if you know that the sides are 6 and 6 of this triangle, and you know one of the base angles measures, for example, 20 degrees, well, then the other one, x, is going to have to measure 20 degrees as well because they're equal. The same is true of the converse, so your converse also has a truth value. If two base angles are congruent, then the opposite legs must be congruent. So for example, if you know the base angles are 40 degrees and 40 degrees, and you know one of the sides, say it's 8. Actually, let's say it's 8 plus x. And this side is going to be equal to 20. Well, you know that 20 must be equal to 8 plus x. So now, not only can you know that both sides are 20, but you can solve for x. Then you can solve for x, ignore that for 1 second. You can solve for x and get that the answer is 12 by subtracting 8 on both sides. Moving on. The takeaway from that, so if you know one of the congruent angles or sides, you can always solve for the other. Equilateral triangles. A triangle which has all three sides of the same length, so all your sides are equal. An interesting property of equilateral triangles, each angle of an equilateral triangle has a degree measure of 60. Because all must be equal, so it's 180 divided by 3. The congruent sides of the triangle imply that all angles are congruent. We can also use the converse of this, which states that if we have three congruent angles in one triangle, that would imply that you have three congruent sides in a triangle. Each of the angles above, or I suppose to the side, so to the side here, is 60. Our first example, solve for x and y. Well, looking at this, I know because it is my congruency marks that these two sides are congruent, making it an isosceles, iso. And I also know that this shows that this angle is equal to 90 degrees. I know that all triangles must sum to 180, So I subtract 90 from that, and I know that what I'm going to have left over after I subtract is 45 and 45. Moving on. Triangle ABC is an equilateral triangle. Solve for x and determine the lengths of the sides. We know that each side here has to be congruent. So all I need to do to solve for x is set two of these sides equal to each other and simplify. So I'm going to move my 4x over to this side, and I get 8 equals 2x, divide by 2, and I get 4 equals x. Now to determine the length of each side, I need to plug x back in. I'm going to do this only one time because each side is equal. So I'm going to multiply this. And I know that 6 times 4 is 24. And that must be true for each side because we know each side is equal. Okay, so triangle ABC has vertex angle A that measures 3 times the measure base angle B. Find the measure of base angle C. Hint, all triangles tend to 180 degrees. So first I have to write my equation, which is 3x. So because we have measure of angle A that's 3 times the measure of angle B, which I will define as x. So 3x, and our two base angles are x. My equation would be each angle is going to sum 280. So I have 3x plus x equals 180. I simplify, and 3x plus 1x equals 5x equals 180. Divide by 5, and I get x equals 36. You can do long division yourself. So that's my answer. Okay, time for the secret hot question. The vertex angle B of isosceles triangle ABC is 120 degrees. Find the degree measure of each base angle. So look at that. Think about the problem we just did. 2. Write the algebraic equation that represents the sum of all the angles of the above triangle. And actually, this problem, you need to solve the whole problem. So you need to do both anyways, but you see it in 2 different questions. And here's your hint. Have a nice night, flippers.